Whether you farm in soil or soilless, pH is a major factor which determines the success of your plants. So what is pH? pH is a measure of how acidic or basic the soil or nutrient solution in the case of soilless farming is at the time of the reading. According to the Britannica, pH denotes potential of hydrogen and translates the values of the concentration of hydrogen ions, which normally range between 1 and 14 gram equivalents per liter, into dimensionless numbers 1 through 14. In pure water, which is neither acidic nor alkaline, the concentration of the hydrogen ion is 10 to the minus 7th gram equivalents per liter. That corresponds to a pH of 7. Anything less than 7 is acidic, and greater is basic or alkaline. Although the chemistry of pH and nutrient interaction is complex, a basic understanding is simple. In agriculture, pH is the most important property of the soil or the nutrient solution in the case of soilless growing, as it is an indication of exactly how the crops will grow. pH is directly related to the plant's ability to absorb essential nutrients. If the solution is too acidic, micronutrients are absorbed by the roots at toxic levels, while macronutrient absorption is lacking. Plants rely on 16 elements to grow and produce maximum yields. Macronutrients consist of nitrogen, phosphorus, and potassium. Secondary nutrients are sulfur, calcium, and magnesium. Micronutrients are iron, manganese, boron, copper, and zinc. And of course, air and water for hydrogen, oxygen, and carbon. Absorption of these nutrients by a plant's roots is directly related to the pH levels, as visually illustrated by this chart. The chart indicates the absorption rates of macro through micronutrients at various pH levels. Nitrogen is best absorbed in a pH range of 6.0 through 8.0. Magnesium uptakes best between 6.5 and 9. Boron's maximum uptake is between 5.0 and 7.0. If you pair this with the nutrient requirements of a specific plant through its life cycle, the pH levels can be adjusted at specific growth phases to optimize the absorption rate of individual nutrients. An example is leafy greens. They rely on micronutrients for proper leaf development. Insufficient micronutrient uptake results in stunted and underdeveloped leaves. Although the chart is a great representation of nutrient absorption, it is not the whole story. In the case of tomatoes, nitrogen, calcium, and magnesium provide heavy vegetative growth, which is exactly the result you need to see in early growing stage. Looking at the chart, it would seem that a pH of 7.0 would be optimum. However, as the plant grows, the resulting excessive high levels of nitrogen, calcium, and magnesium will be detrimental to the reproductive growth phase and introduce deficiencies of potassium and iron. So a pH plan for tomatoes would be to start out with a pH of 6.0 to 6.5 to maximize the nutrient uptake of the growth phase nutrients. As the tomato enters the flowering and fruiting phase, the plant will require much more potassium, especially as potassium is important for fruit development and especially flavor in tomatoes. Lowering the pH to a range of 5.5 to 6 will slow the absorption of growth nutrients and increase the absorption of flowering and fruiting nutrients, which are potassium and iron. This table shows the potassium-nitrogen ratios for typical tomatoes through the stages of growth. So the bottom line is the pH level of the nutrient solution sets the conditions for maximum absorption, and the nutrient makeup of the solution determines what level each nutrient is available to be absorbed. With that being said, a pH ratio of 5.5 to 6.5 is considered optional for the range of hydroponic farming. Here is a table of optimum total dissolved solids and pH values for various plants. So how do we adjust pH? Good question. When you initially blend the selected nutrient mix, aggressive vegetative growth is good for just about every leafy green. Now, we use reverse osmosis processed city water, which yields a product of less than 10 parts per million of dissolved solids and a pH of 7.0. Mixing the nutrients in the order suggested by the nutrient manufacturer will shift the pH of the resulting solution. In this case, our pH dropped from 7.0 to 5.5. The most reliable way to adjust the pH level in the reservoir is by using commercial pH adjusting concentrate solutions. We are using pH up and pH down by General Hydroponics. However, there are many brands available and different price points. Although there are other methods of adjusting pH in the nutrient solution, they tend to leave undesirable elements in the solution that'll actually adjust the total dissolved solids of the solution, giving false nutrient readings. Before we add the pH correcting solution, record the pH reading in your log. This also includes the temperature of your solution. Now that brings up another topic, how to measure pH. There are several methods of measuring pH. The most reliable, in my opinion, is a titration method. Not as convenient as a meter, but you can't fool a molecule. A sample of the solution is taken using the 3-dip method, and 3 drops of reagent are added. The vial is gently mixed, not shaken, and the resulting color of the solution is compared with the color ranges on the bottle. In this case, 5.0 appears to be the closest color. Good lighting greatly assists in determining the color comparison.